5.1, we're talking about rate of change. The rate of change is how quickly a line increases or decreases. Another word we use for rate of change is slope. Huh? Some other things we use that also mean rate of change or slope. We say the change in y divided by the change in x. Another phrase we also use that means rate of change or slope is rise over run. You'll notice everything we're doing is all in fraction form, and that's how we're going to leave it. Okay? The last one is an equation we can use in order to find it. That equation is y2 minus y1 over x2 minus x1. So, continuing, we can find slope from many different ways. We can find slope from a table, a graph, and 2 points. So let's start with the table first. All right? So to find slope from a table, you have a table. You have your x and y values. You are going to subtract or do loops on each side. So for example, if I have 1, 3, 5, and 7 on the x side, and on the y side I have 4, 7, 10, and 13. To do it from a table, we're going to do our loops. This time, we're not going to do it just on the right. We're going to also do it on the left. So on the left side, we have 3 minus 1 is 2, or the difference between the first two is 2. 5 minus 3 is 2. 7 minus 5 is 2. Then we got to go to the right-hand side and do the y's. 7 minus 4 is 3. 10 minus 7 is 3. 13 minus 10 is 3. Now, one of the ways we said we can find rate of change is the change in y divided by the change in x. So when you're doing a table, that's how we want to think of it. The change in y is what value? The y side, the change is 3 over the change on the x side is 2. That's our rate of change or our slope. All right, so here's example number 1. Example 1, which will cover the first 2 problems in your homework, 8 through 10. Find the rate of change. Oops. And explain what it means. So here's our table. In our table, instead of having x and y, let's say we have time and, you want money? Okay, money it is. All right. On the left-hand side, or our x side, we're going to say we have 1, 3, 5, and 7. And on the money side, let's say we have 10, 20, 30, and 40. So the first thing we have to do is find the rate of change. Doing our loops, right? 3 minus 1 is 2. 5 minus 3 is also 2. And 7 minus 5 is 2. Going to the right-hand side, 20 minus 10. Good. All right. So can you help me out? What exactly is our rate of change here? Good. It is. So our change in y is 10. Our change in x is 2, which equals 5. Now, I need to know what that means. It means something. It does. Okay, so think about, we have the change in y is money. So it's $5 over, we're going to say time because I didn't specify whether it was hours or minutes, right? But could have been a day. That's true. That would be very sad if that's all you made a day, but. All right, so any questions on doing it from a table? Pretty easy? All right, so now let's talk about from a graph. No, I didn't. All right, so if we have a line on our graph we have here, so let me see. All right, you guys. So let's say we have a line that goes from here to here. When we are finding it from a graph, or finding rate of change from a graph, you are going to do rise over run. Exactly what we did with our Christmas trees before break. You always start with the leftmost point. So start on the left, start on left point, start at left point, which is this one, and we either go up or down to get to the next one. If we go up, it's positive. If we go down, it's negative. So in this case, we're going to count down 1, 2, 3, 4. So that's a minus 4 on top. And we always run to the right. Now, count right. So from here, we're counting 1, 2 to the right. So our slope is going to be negative 2. I forgot the W. I'm sorry, guys. All right. So let's try another one. Let's say I have a point that goes from here to here. Let's say we have a point that goes from this one to this one. Okay, so we're going to start at the leftmost point, which is this one, right? We start by counting up or down. Do I got to go up first or down first? So 1, 2, 3, 4. So my top number is 4, and then I count to the right. 1, 2, 3, 4, 5. So my slope is 4 over 5. Okay, so here is example number 2. Huh? I was explaining it. Now, example number 2. Let me get it all written up here to the best of my ability. Alright, so example number 2, this is going to be numbers 12 through 16. No, it's only 4 problems. 3 problems, sorry, 3 problems. Not too many. Yeah. Okay. How many guys listen? So we're going to start at the leftmost point. Starting at the left one is this one, right? Everybody understands their left and their right? Okay, just making sure. So starting at the left, am I going to count up or down first? Up. 1, 2, 3, 4, 5, 6. So 6 goes on top. Then I always go to the right. 1, 2, 3. I didn't. I was here, and I got to go 1, 2, 3 to the right. No. Okay, so our final answer would be 2. Do we have a question? Do we have a question, you guys, at all? I know that. All right, so let's... So now let's talk about from 2 points. When we are finding the rate of change or slope from 2 points, we are going to have our first point is our x1, y1 point, and our second point is our x2, y2 point. And we use the equation y2 minus y1 over x2 minus x1. Okay, so if I had the points, let's say 3, 7, and a point 5, negative 2. All right, so this first point, I'm going to label as my x1, y1. The second one is my x2, y2. So the very first number I need is y2. Willie, what point is y2? Negative 2 minus, what's y1? 7. I agree. Over x2 minus x1. Now we simplify. On the top line, negative 2 minus 7, Thomas. Negative 9. Over, whoops. We have negative 9 over 5 minus 3. 2. All right. Okay, so all of these are going to follow putting it into this equation each and every time. Okay, guys. So here is example number 3. Example number 3 covers problems 18 through 22. Find, okay, gentlemen, the rate of change. And I'm going to give you 2 points. The first point, let's say is 3. Oops, let me clean that up a little bit. Sorry about that. 3, negative 1. And the second point is 9, 2. All right, so I want to remind you our formula is y2 minus y1 over x2 minus x1. And I like to go up here and kind of label it right above x1, y1, x2, y2. All right, so my y2 value minus y1, good, over x2 minus x1. All right, so you'll notice in the top line we have a sandwich, right? So what are we going to get for the top line? It is 3, I agree. And the bottom, 9 minus 3. Can I simplify this? Good. 1/2. All right, guys. I still have no see-it-through, so you're wasting my time. You're actually wasting yours. All right. Any question on plugging it into this equation? No questions whatsoever.
How do we do it?
All right. So the next thing I want to talk about is we have some special cases. These are special. Special rates of change, gentlemen. Thank you. All right. Special rates of change are if you have a horizontal line, the rate of change of a horizontal line. If I had a line that's set like this, and I set, yeah, it's straight, right? If I put a car on top of that, how much is that car going to move? Zero. So the rate of change for a horizontal line is zero. Exactly. All right, for a vertical line. For a vertical line, if I had a line going up and down like this and I set a car on it, what would happen to the car? It would fall. It would crash, right? So our slope for a vertical line is undefined. Now, it is undefined when you do rise over run and you get a number over 0. So if the 0 is in the denominator, that means you're not running right or left 0, right? So it's a vertical line. So here's where I want to talk about it. If I have, all right, let's say I have a horizontal line from here to here. What is my slope of this line? It is 0, right? If I have a vertical line from here to here, what is the slope for this one? Undefined. I agree. Huh? No, you got to say undefined. All right, so here's example number 4. Find the rate of change. So, say I have 3, gosh darn it, 7, and let's say I have 3, -2. So again, this is my x1, y1. This is my x2, y2. All right, so y2 is -2 minus y1, which is 7, over x2, which is 3, minus x1, which is 3. So -2 minus 7 is -9. 3 minus 3 is 0. So what does this mean? Undefined. Thank you, Devin. This is undefined. So, hey, if this is undefined, what kind of line do I have between those 2 points? It's a straight one. What kind of straight one? Vertical or horizontal? Vertical. Guys. Did I say I missed y'all? Did I say that? All right. So, last thing I want to talk about is, in Chapter 4, we talked about x. X is your independent variable, right? Y is your dependent variable. So if I have a point, xy, not yet, this is independent, and this is dependent. Okay, so in the next example, you are going to have to set up 2 points with your independent and dependent values. Then find their rate of change. So here is example number 5. This is going to cover 26 through 32. Hey, guys, that's enough. I am done. Thank you. All right, so let's say a babysitter makes $9 for 1 hour and $36 for 4 hours. Find the rate of change. So, we need to talk about the dollars and the hour. Which one is independent and which one is dependent? Time is always independent. You guys are right. So remember, this time over here is actually going to be our X values, and that means our money is going to be our Y values. Very good. Kind of putting it all together now. So the first point we have is our X is 1, our Y is 9. Our second point, X is 4 and Y is 36. So now we have to find the rate of change. Okay, this is my X1, Y1. This is my X2, Y2. Y2, 36, minus Y1, 9. Over X2, which is 4, minus X1, which is 1. I'm sorry, Thomas, I apologize. 36 minus 9 is 27. 4 minus 1 is 3. What does that simplify to? It's not 0 on the denominator, though. It's over 1, right? So this is actually 9. And can you tell me what it means when you talk about this rate of change? What does 9 mean? It's technically 9 over 1. What is it, Devin? Okay. Yes, this actually means that it's $9 per hour. I know. I gave you an easy one to start with. So, do you need another example of this? I know. Do you need another one like this? So you guys are going to be totally good in the last few problems setting them up. Okay. All right, your homework then today is on page 298, 299, numbers 8 through 32 even. Yes, it is posted in Google Classroom already. You don't have your, I can loan you a book, that's fine.